This lesson is on roots and vertex. So you know what roots are actually. They're the x-intercepts, but we're just going to give them a different name to be more precise. So roots, to start off with, let's look at a tree. So a tree, you have the pretty stuff on top, the trunk, and then as soon as you get to ground level, the roots start to form, or that's where we say the roots begin. That's the same thing when we're talking about graphs, except our ground is the x-axis. So if I draw in my coordinate plane, and I have, say, a line, where it crosses the x-axis is what we call a root. So a root is an actual point, an x and a y point. But we're going to actually talk about quadratics. So quadratics have that parabola shape, like so. Now, because they have that parabola, they can have more than one root. For example, this one has two. They also may be able to just have one, where it just touches the x-axis, or it may have none, one floating out in space over here. But roots, they are the x-intercepts. Okay? Or you can think about them as when f of x is equal to 0, when your function is equal to 0. Before we were saying when y was 0, but remember we're getting into this function notation, so we're thinking about it when the function f of x equals 0. Okay? Now, how do we find roots? Well, we just talked about when the function is equal to 0. So if our function, for example, was f of x equals 2x plus 4, set that equal to 0, and then all you have to do is solve for x. So this one would be negative 4 equals 2x, negative 4 divided by 2 equals x, so negative 2 is equal to x. Now that's the x value, that's not the actual root. You have to substitute this in back into your equation to find the actual root. So that would be, if you had f of negative 2 is equal to 2 times negative 2 plus 4. Okay, so doing that, you will get out negative 4 plus 4 equals 0. And that makes sense, right? Because we said we were going to have this equal to 0. We were saying that our y coordinate was going to be 0, so that when we plug this in, it's going to equal 0. So we did it. So this root is negative 2 comma 0. Make sure you're writing it in coordinate form. Now, we have this function over here, x squared plus x minus 20. We want to find its roots, but if we just simply set it equal to 0 like we did over here, we're going to run into some problems. We're probably going to add this 20 over, but then we're left with x squared plus x. What do we do with that? We could take out an x and divide that over, but now we have x's over on the left. It's just a big mess. So what we want to do is factor it, and we're not going to do this in this video, but we're going to learn about it eventually or review it. But for now, I'm just going to tell you this is the factored form of this equation right here. They equal the same thing. If you graph them, they're going to look exactly the same. But this one helps us find the roots, because if we set it equal to 0, and this is a minus 4, just so you know, I accidentally started writing a plus, we can set each separate part equal to 0. So we could say x minus 4 equals 0, and x plus 5 equals 0, and solve them separately, so that x is equal to 4 and x is equal to negative 5. So I just subtracted the 5, I added the 4 over. Now, again, these are not our roots. We have to substitute them back in to our equation to find them. But remember, we don't need to, because we set it equal to 0, so we know that these roots, all you have to write is 4 comma 0 and negative 5 comma 0. So those are our two roots, because a root is when the function is equal to 0, when y is 0. Alright, so if we're trying to plot that, I would go over 1, 2, 3, 4. There's one root. And then I go over 1, 2, 3, 4, 5. There's my other root. Now we have to look at vertex. Now a vertex is the changing point. So for our example right here, the vertex is where it stops increasing and now it begins to decrease. So it changes from increasing to decreasing. In this parabola right here, the vertex is right there because it changed from decreasing to now the slope is increasing. Okay? The nice thing about parabolas is that they're symmetric. So that looks more like a U, but they have this symmetry where if you flip it over on top of itself, it's going to match up perfectly if you have that line of symmetry right down the middle. So when we're looking for our vertex, it's on that line of symmetry. So we just have to find the halfway point between our two roots, because that will help us find the symmetry line. So how do we find the distance between those two? The halfway distance? Well, let's look at it like midpoint. So midpoint, you take your x1 minus your x2 and divide it by 2. It's like a distance. Okay? Let's do that same thing right now. So we have 4. Let's subtract away negative 5 divided by 2. So we have 9 over 2. That is our distance from each point to that middle line, that line of symmetry. Okay? So that isn't the vertex. We have to actually find the x value of the vertex. So you can think about it as 9/2 from this point or 9/2 from this point. If we're going from this negative 5, 0, we're going to have to add. If we're going from the 4, 0, we're going to have to subtract. Let's go from the negative 5, 0. So if we have negative 5, we want to add, go to the right 9/2 to get to our vertex. So that would be negative 10 over 2 plus 9/2, which is equal to negative 1/2. So that is our x value of the vertex. So at 1/2, when x is equal to negative 1/2, our vertex is somewhere there. But we don't know where it's at, but we can find out. Let's just substitute this in to our equation. Now you can do it into this equation or you can do it into the original equation. I am going to do it into this factored form equation. Okay, so bear with me, we're running out of room here. So let's put f of x of 1/2. Remember that function notation? Equals, so I'm going to put a 1/2 wherever I see an x, minus 4 times negative 1/2 plus 5. Okay? Now, gotta love fractions. We have to convert these, so 1/2 minus 8/2 times negative 1/2 plus 10 over 2. Make sure you know how to do those. So we have negative 9 over 2 times positive 9 over 2. Excuse me. Multiplying fraction, multiply the numerators, and multiply the denominators. And this is going to come out to negative 20.25 if you want an approximation. So what that means is that when x is negative 1/2, y is negative 20.25. So our vertex is the point negative 1/2, comma, negative 81 over 4. So that, let's just say it's somewhere like right here. Negative 1/2, negative 81 divided by 4. So we can actually draw in our parabola now. It just has to go through the roots, come on down, changes at the vertex, comes on back up, and then we don't really care what it does after that. So let's look. We were given an equation and we graphed the parabola. We did it all by ourselves, no calculator needed. Alright, so I have one example for you now. And, oops, right here. Here's your example. Find the roots and the vertex of f of x equals x minus 3 and x plus 1. So I put it in factored form for you. So go ahead, pause the video right now, and see if you can do that. Alright, so here are the answers. The roots should be 3 comma 0 and negative 1 comma 0. Alright, so you're setting each of these equal to 0 and then solving. And then the vertex, you should have found a distance of, let's see, 2. So these are 2 apart. Or if you go 2 from 3, 0, if you go 2 from negative 1, you're going to be at the same line of symmetry. So your vertex, the point should be negative, or 1 comma negative 4. Okay? So that's our little example. I didn't show you the work, but if you want to draw the graph, you can go over 1, 2, 3, over 1, and over 1, down negative 4. 1, 2, 3, 4. And there's your parabola. Alright, so make sure you do the problem assigned with the video, and we'll see you in class.